Hey everyone, and welcome back to the channel. Today we're diving into a story that literally lit up the world. Now we're talking about electricity. We use it every single second of our lives, but have you ever stopped to wonder how we went from rubbing amber to powering entire cities? It's a tale filled with curious minds, shocking experiments, and a whole lot of static. Our story begins way back around 600 BC with the ancient Greeks. A philosopher named Thales of Miletus was just messing around, as philosophers do, and he noticed something peculiar. When he rubbed a piece of amber, which is fossilized tree resin, with a bit of fur, it suddenly gained this weird power. It could pick up light objects like feathers and dried leaves. The Greek word for amber is electron, and that's where we get our modern word electricity. For a long time, this was just a neat little party trick, a fascinating but useless curiosity. Nobody really knew what was happening or why. Fast forward over 2,000 years to the 1600s. An English physician to Queen Elizabeth I, a guy named William Gilbert, decided to take a closer look at Thales's amber effect. Gilbert was a methodical guy. He started rubbing all sorts of things together: diamonds, glass, sulfur, and found that many of them could create this same attractive force. He was the one who coined the Latin term electricus to describe this property. He even built a device called a versorium, which was basically a lightweight metal needle balanced on a pivot to detect static charges. This was the world's first electroscope. Gilbert proved that this force wasn't just a quirk of amber, it was a more general phenomenon. But still, the big question remained: what asterisk was asterisk? The 18th century is when things really started to spark. Imagine a world lit by candles and powered by muscle. Into this world comes a parade of brilliant and sometimes downright eccentric scientists. One of the early pioneers was Stephen Gray in England. In the 1720s, Gray discovered that this electrical virtue, as they called it, could travel. He generated a static charge on a glass tube and found that the charge could be transferred along a damp hemp thread for hundreds of feet. He even suspended a young boy from the ceiling with silk cords, which do unconduct electricity well, and showed that when he touched the boy's feet with the charged glass tube, the boy's face and hands could then attract small bits of paper. He had just discovered electrical conduction and insulation. This was a massive breakthrough. It wasn't just a stationary force, it could flow. Around the same time, a Frenchman named Charles-François Dufay was doing his own experiments. He discovered that there seemed to be two different asterisk kinds: asterisk of electricity, called them vitreous from rubbing glass, and resinous from rubbing resinous materials like amber. He noticed that objects with the same kind of electricity repelled each other, while objects with different kinds attracted each other. This was the first hint of positive and negative charges, the fundamental law of electrostatics: opposites attract and likes repel. Then things got a bit more explosive. In 1745, in the city of Leiden, Netherlands, a physicist named Peter van Mastenbroek was trying to store this mysterious electrical fluid. He set up an experiment where a wire ran from an electrostatic generator into a jar of water he was holding. His assistant cranked the generator, and when Mastenbroek touched the wire with his other hand to disconnect it, he received a massive shock that threw him across the room. He later wrote that he would not take a second shock for the Kingdom of France. He had accidentally invented the first capacitor, a device for storing electrical charge, which became known as the Leyden jar. The Leyden jar became the hottest scientific toy in Europe. Scientists and showmen held public demonstrations, giving shocks to brave volunteers and creating impressive sparks. It was through these experiments that people began to notice a similarity between the sparks from a Leyden jar and a much grander, more terrifying natural phenomenon, lightning. And this is where one of the most famous names in the story of electricity enters the picture: Benjamin Franklin. Franklin was a polymath, a printer, a politician, an inventor, and he was utterly fascinated by electricity. He theorized that lightning was just a giant version of the static sparks he saw in his lab. To prove it, he proposed a dangerous experiment. Most people know the story of the kite and the thunderstorm, but it's often misremembered. Franklin was smart enough not to want to get fried. His plan wasn't to get the kite struck by lightning, but to draw the electrical charge from the storm clouds down the wet kite string. In 1752, during a Philadelphia thunderstorm, he flew a kite with a metal key tied to the string near his hand. He made sure to hold a dry silk ribbon that was tied to the string, insulating himself. As the storm clouds passed overhead, he noticed the loose threads of the hemp string standing on end. He then brought his knuckle close to the key, and a spark jumped between them. He'd done it. He had proven that lightning was electricity. This discovery was huge. Not only did it demystify one of nature's most frightening forces, but it also led to a practical invention, the lightning rod, which has saved countless buildings from fire. Franklin also refined the theory of electricity, proposing that it was a single fluid, and introduced the terms we still use today, positive and negative. So far, all the electricity people were playing with was static electricity, a buildup of charge that discharged in a quick zap. The next great leap was figuring out how to create a continuous, steady flow of electricity, current. This breakthrough came from an unlikely source, a debate about frog legs. In the 1780s, an Italian physician named Luigi Galvani was dissecting a frog. He noticed that when his metal scalpel touched the frog's leg nerve, while an electrical machine was running nearby, the leg twitched violently. He later found he could make the leg twitch just by touching it with two different types of metal, like brass and iron, without any external electricity source. Galvani believed he had discovered animal electricity, an inherent life force within the muscles. Another Italian scientist, Alessandro Volta, was skeptical. He thought the electricity wasn't coming from the animal itself, but from the two different metals reacting with the frog's bodily fluids. To prove his point, he started experimenting with different combinations of metals and liquids. He discovered that if you stack discs of two different metals, say zinc and copper, and separate them with a piece of cloth soaked in salt water or a weak acid, you could generate a steady electrical current. In 1800, he announced his invention, the voltaic pile. This was the world's first electric battery. It was a stack of alternating zinc and copper discs, separated by brine-soaked cardboard. When a wire was connected to the top and bottom of the pile, a continuous current flowed. For the first time in history, humanity had a reliable, portable source of electricity. The unit of electrical potential, the volt, is named in his honor. Volta's battery changed everything, transformed electricity from a scientific curiosity into an incredibly powerful tool. Scientists now had a way to study electricity in a controlled manner. In the years that followed, this led to a cascade of incredible discoveries. In 1820, a Danish physicist named Hans Christian Ørsted was giving a lecture. By pure chance, he had a compass sitting near a wire connected to a voltaic pile. When he switched the current on, he was astonished to see the compass needle twitch and point away from north. When he switched the current off, it went back. He had just discovered the link between electricity and magnetism. An electric current creates a magnetic field. This was the birth of electromagnetism. News of Ørsted's discovery spread like wildfire. In England, a brilliant but self-taught scientist named Michael Faraday took it a step further. If electricity could create magnetism, he reasoned, could magnetism create electricity? Spent years trying to prove it. Finally, in 1831, he made the breakthrough. He found that by moving a magnet inside a coil of wire, or by moving a coil of wire through a magnetic field, he could induce an electric current in the wire. This principle is called electromagnetic induction, and it is the foundation of almost all electricity generation today. Every power plant, whether it's coal, nuclear, hydro, or wind, uses this exact principle. They all use some force to spin a turbine, which spins a giant magnet inside massive coils of wire, generating the electricity that flows to our homes. Faraday had invented the electric generator, and in doing so unlocked the secret to generating vast amounts of power. From there, the age of electricity truly began. Innovators like Thomas Edison didn't invent electricity, but he perfected a system to use it. He developed a practical, long-lasting, incandescent light bulb, and, just as importantly, built the first commercial power station and distribution grid in New York City in 1882 to power those bulbs. At the same time, Nikola Tesla was pioneering alternating current, or AC, which could be transmitted much more efficiently over long distances than Edison's direct current, or DC. The ensuing war of the currents eventually saw Tesla's AC system win out, becoming the standard for power grids worldwide. And that, in a whirlwind tour, is how we captured lightning in a bottle. It's a story that stretches from ancient Greece to 19th century laboratories. It's built on the curiosity, ingenuity, and sometimes sheer luck of countless individuals. Each one added a piece to the puzzle, from Thales rubbing amber to Faraday moving a magnet. Leading us to the electrically powered world we know today really makes you appreciate the simple act of flipping a switch. Thanks for watching, everyone. If you enjoyed this journey through scientific history, be sure to hit that like button and subscribe for more stories behind the science that shapes our world. See you in the next video.